Okay, who is there? Just message, type a message. Okay, write down the question. Okay, write down the question. Write down 4 important characteristics. Write down 4 important characteristics of image formed by the plane mirror. Okay, write down 4 important characteristics of image formed by the plane mirror. Okay, so plane mirror forms which kind of images? They can form virtual, erect and laterally inverted. Virtually erect and virtual, erect and laterally inverted. Laterally inverted images they can form, as well as the image is same as the size of the object. So image is same as that of the object. Okay, so these are the 4 important characteristics characteristics of the image which are formed by the plane mirror. So virtual, they are erect, laterally inverted, image is same as that of object. So these are the important characteristics. Okay, getting this? I will not give I will not dictate the answers, but just I will discuss these answers. Okay, write down. Next question. The radius of the curvature of a spherical mirror is 20 centimeter. The radius of the curvature of a spherical mirror is 20 centimeter. Find its focal length. Okay, so here radius of curvature is given, that is 20 centimeter, and they are asking us to find out the focal length. So focal is nothing but what? R divided by 2. That means we have the formula R is equal to twice of F. So now I want F, means rearrange the terms for F. So R by 2, and here this will come 20 by 2, that is nothing but 10 centimeter. The focal length is here 10 centimeter. Copy this. Now write down the next question. Light enters from air to glass. Light enters from air to glass having refractive index 5.50. Full stop. What is the speed of a light? What is the speed of a light in the glass? What is the speed of a light in the glass? Question mark. Speed of the light in a air is 3 into 10 raised to 8 meter per second. I'll repeat this. Light enters from air to glass having refractive index 1.50. So what is the speed of the light in the glass, and speed of the light in the air is given 3 into 10 raised to 8. Okay, so refractive index is given. So write down the given values first. Refractive index n is nothing but 1.52 and 1.50. Okay, and refractive index velocity of a light in the air is 3 into 10 raised to 8 meter per second, and we have to calculate velocity of a light in the medium. Okay, and we have the formula refractive index is equal to C by V, correct? So we have to find out V. So I'll rearrange the values for V. C by N. So C is 3 into 10 raised to 8 divided by 1.50. Okay, so you can simplify, this is 300 divided by 150 into 10 raised to 8. Remove the decimal point, so 151s are 150, 152s are 300. So answer you will get 2 into 10 raised to 8, unit is meter per second. Getting this? 1 or 2 mark question is this. Copy this. Getting the answers, how I am calculating? Okay, so everyone copied this. Write down the next question. The refractive index of a diamond, is 2.42. What is the meaning of this statement? What is the meaning of this statement? Okay, so I will repeat this question. The refractive index of a diamond is 2.42. What is the meaning of this statement? Okay, so we know that refractive index table is given in the textbook. So diamond is having or possessing more refractive index. That means the speed of light is very slow in the diamond. Okay, so here meaning of the refractive index of a diamond is 2.42, is that speed of the diamond is 1 upon 2.41 times the speed of the light, okay, in the air by vacuum. Okay, so here we can write it as, here refractive index of the diamond is given 2.52. okay, and just now we did n is equal to C by V. So here V is nothing but what? We can take 3 into 10 raised to 8. By default velocity of a light in the air is 3 into 10 raised to 8, and here n is 2.52. So if you calculate this, you will get the answer. Just calculate this, 3 upon 2.52 is nothing but 300 divided by 252. Find out this, how much is the division comes. Uh, 300 divided by 252 is, I think, 1.190. okay, 1.190 into 10 raised to 8 meter per second. So this much speed is there of the medium. So if the diamond contains a refractive index 2.52, then speed of light in the diamond is 1.90 into 10 raised to 8 meter per second. Velocity means speed is what get decreased when it enter into the diamond. Getting this? So they will ask this for 2 marks. Then you have to write the reason and solve this question. Okay, write down the next question. Write down. What should be the position? So next question, first bit is there. Next question, first bit. What is the position? What is the position of the object? What is the position of the object? Object when a concave mirror is to be used. When concave mirror is to be used. First bit, as a shaving mirror, and second, in torches, producing a parallel beam of light. So same question, B part is there, copy that part. A man standing in front of mirror. A man standing in front of mirror. A man standing in front of the mirror finds his image having a very small head and legs of normal size. So what type of mirrors are used in designing such mirror? Question mark. So I will repeat this entire question. What should be the position of the object when a concave mirror is to be used? First, as a shaving mirror, and second, in torches producing a parallel beam of light. And second bit is there, a man standing in front of the mirror finds his image is very small head and leg of normal size. What type of mirror are used in designing such mirrors? Okay. So here in first question they are asking what should be the position of the object when the concave mirror is used. Okay. First as a shaving mirror. Okay. So basically shaving mirror we are using to get the enlarged and erect image. Okay. If I am getting inverted image, then no use, no. So here we are using concave mirror for the shaving. Shaving mirror is nothing but what? Concave mirror, because it gives what? The erect image. Okay. Erect as well as it gives the enlarged image. Okay. So here they are asking what is the position. Position is what? Object should be what? Looking towards the pole. Object should be looking towards the pole, because here as they are using concave mirror. So this is a concave mirror, then object if we are keeping in front of the pole, then only the image will form on the mirror. Getting this? So object is what? Pointing towards the pole, then only I will get enlarged and erect image. Okay, then only the position they are asking. So position is what? Towards the pole. And now next question is there, a man standing in front of the second bit, in torches producing a parallel beam of light. So here also concave mirror we are using, but they are saying parallel beam of light. So in textbook what is the question, how the statements are given? Basically in torches or headlights we are using what? The concave mirrors. But as they are forming parallel beam of light, there is a combination of parallel mirrors. There is a combination of plane mirrors, not parallel, plane mirrors, plane and concave mirrors. Okay, because of that they can focus and they can produce the parallel beam of light. That's it. This is the answer. And here they are asking the position. No, then position is nothing but what? At focus. Because the all the rays are what? Gathered over here. Means the light rays are coming here and they are gathered over what? At focus. So position is what? Here focus, and here what? The answer is pole. So this kind of questions also sometimes they will ask, but it's very difficult, you know, they are asking position and we are giving other explanation. That is wrong. I know concave mirrors are used in the shaving, as a shaving mirror, as well as in torch or headlight they are using concave mirrors. But we should know why the concave mirrors are using as a shaving mirrors, because they always gives the always gives the erect and enlarged image. So the object is pointing towards the pole. So here position is what? Pole. And whenever they form, as we are using in torches, that means what? Parallel beam of light is producing. So all the rays which are coming from the infinite from the infinite distances, they all gathered at a focus. Okay. So here position is what? Here focus. Understood? So writing the correct answers, means if you are writing only pole and focus also, you will get 1 mark for each bit. Okay. So now second bit is what? A man standing in front of the mirror finds the image having very small head and legs of normal size. So what type of mirrors are used in designing such mirrors? So they are using here head is small and legs are normal. That means they are using here convex mirror and plane mirror. They are using both combination of both the mirrors, so that head will become small and legs are become, means whatever the normal image is, normal object is there, so normal legs we can able to see, but one part is what gets contracted, or that is a smaller one, and we are getting smaller images only in convex mirrors. Okay, getting this? So combination of convex mirror and plane mirror. In plane we will get what kind of image? Same size, no? So leg is same size, but head is what? Small. It is what get reduced, means size is very small. That means convex, and here plane mirror. So convex is for small head, and this is for normal legs. If they are asking head is enlarged, means you can write concave mirror. Getting this? Copy this. Write down next question. For the same angle of incidence, in a media P, Q, R. For the same angle of incidence in a media P, Q, R, the angles of refraction are 45 degrees, 35 degrees and 15 degrees respectively. Full stop. In which medium will the velocity of light be minimum? In which medium will the velocity of light be minimum? Give a reason. Give a reason. Okay, I will repeat this question. For the same angle of incidence in a media P comma Q and P comma Q comma R, the angle of refractions are 45 degrees, 35 degrees and 15 degrees. In which medium will the velocity of the light will be minimum? Give the reason. Okay, this is also IMP question. Who all are there? Just type a message. Let me check who all are there. Type a message. Who all are there online now? Marva, are you there? Marva? Anahita? Vidhi, are you there? Alya? Jivitesh? Let me check how many people are there. Only 2 were messaged. Okay, leave it. So here, this question is IMP. Mark it as a IMP. Here they are saying angle of incidence will remain same for P, Q and R. Okay. Here, just wait. You can write the answers point wise. I am just explaining. Here we have P, Q and R, and angle of incidence for all the 3 medias are same. But angle of refractions are given here 45 degrees, 35 degrees, no? Yeah, 35 degrees and 15 degrees. Okay, and they are asking what is, in which medium the velocity of a light will be minimum. Velocity of a light will be minimum. So I know n is equal to c by v. But the problem is that here we can't relate with these given angles. Okay, but one more formula we have. The refractive index n is nothing but what? Sine of I by sine of r. That is a Snell's law. Don't take lightly Snell's law. 100% there is a question will come in the board exam. So sine I by sine r. So can I write here c by v is equal to sine I upon sine r. Okay. So I will write here. They are asking velocity of a light in what? In a medium. So we can write here v. Okay, here I will write it as V, I will transpose here equal to what? C into sine of R divided by what? Sine of I. Can you getting this? Okay. So here if you take this is, suppose if they are asking for 3 marks, so you have to substitute the value and find out the answer. They are asking what? The same, no? Yeah. So you will get this. So now angle of incidence everywhere same. Okay, and they are asking what? Angle of refraction. In which medium the velocity of a light will be minimum, they are asking. Okay, angle of incidence same and angle of refraction is what? Changing. So if you take for first P, okay, so P will come what? If you want, I will write here. So Vp is nothing but C into sine of 45 divided by what? Sine of I. So VQ is nothing but C into sine of 35 divided by sine of I. Okay, VC, so VR is equal to C into sine of 15 divided by what? Sine of I. So these are the angles we will get. So now here angle of incidence is same everywhere. Then here velocity in the medium is less where they are asking what is the velocity, in which medium velocity is less. How can you find out? Here angle of incidence is 15, no, sorry, angle of refraction is 50 and it is multiplied by 3. Here 35 is there and here 45 is there. So obviously here you will get which value will become less. Check. Whenever, always remember, whenever this kind of questions you will get and you don't know, I know only the angles are same. So always for minimum value of refraction, velocity is also minimum. Okay. For minimum value of angle of refraction, the velocity is also minimum for that medium. And then we can say here the velocity of the speed of the speed in a medium r is very less. For a medium r is very less. Getting this? This is 2-mark question. Okay, write down next question. As the velocity of a light increases, as the velocity of a light increases, as the velocity of a light increases, comma, the refractive index of the medium, decreases, full stop. Light enters from air to water, having refractive index 4/3. Find the speed of a light in water. Find the speed of a light in the water. Full stop. The speed of a light, the speed of a light in a vacuum, the speed of a light in the vacuum is 3 into 10 raised to 8 meter per second. 3 into 10 raised to 8 meter per second. Okay. So I will repeat this question. As the velocity of a light increases, the refractive index of the medium is decreases. Okay. So light enters from air to water having refractive index 4/3. Find the speed of the light in the water. The speed of the light in the vacuum is given 3 into 10 raised to 8 meter per second. So speed of a light in the vacuum is nothing but speed of a light in the air, that is given. Okay. So here we have to calculate the speed of the speed in a water. Okay. So first write down the given things, read the question properly and find out the refractive index for which medium they gave the refractive index. The light is what enters from air to water. Okay, so air to water. So here we can write refractive index of a water with respect to air, and that is given how much? 4/3. Can you get it? The question how we have to write? And then here speed of a light in the air or vacuum is always 3 into 10 raised to 8 meter per second. And we know that refractive index n is equal to what? C by V. So C is nothing but speed of a light in the air, the speed of light in the medium. So medium is here water. I want to calculate speed of a water in a speed in the water. So here C by n. C is nothing but 3 into 10 raised to 8, and here 4/3. 3 is also get reciprocal, and I will get 9/4 into 10 raised to 8 meter per second. Now do this division. 9/4 it is 2.25 into 10 raised to 8 meter per second. So this is what the answer. Very simple 2-mark questions are there. Many times students are ignoring this refraction, but this chapter, this point is very important. Those who are going for science also, for them same chapter we have. Okay, finished. Everyone copied. Write down next question. For same angle of incidence 45 degrees. For the same angle of incidence 45 degrees. For the same angle of incidence 45 degrees. The angle of refraction in two transparent media 1 and 2 is 20 degrees and 30 degrees, 20 degrees and 30 degrees respectively. Out of 1 and 2, which medium is optically denser? Which medium is optically denser and why? Okay. So here diagram is given. I will repeat first. For the same angle of incidence 45 degree, the angle of refraction in two transparent media, that is 1 and 2, is 20 degree and 30 degrees. Okay, respectively. Out of 1 and 2, which medium is optically denser and why? So I will draw the diagram that is given. Okay, so this is medium 1, this is medium 2. So this is the angle of incidence. Okay, this is nothing but normal. This 45 degree angle of incidence, and this is nothing but 20 degree given. This is the figure 1. Okay, and in figure 2, this is the normal, and here angle of incidence is nothing but 45 degrees. Okay, and angle of refraction is given 30 degrees. Okay, so this is what your second figure. They are asking which medium is optically denser. Okay, so we know that whenever the ray of light is traveling from air to denser medium, then it is always bends towards the normal. Okay, and whenever the ray of light is traveling from air to denser to air, it is bend, it moves away from the normal. So if you observe these two diagrams, so here angle will remain, angle of incidence will remain same, but here means here deviation towards the normal, and here deviation away from the normal. That means we can conclude here the figure 1 is nothing but what? Denser medium. Okay, this is nothing but what? The denser. So which figure is what they are asking? Which figure or what? Yeah, which medium is optically denser over here? So first figure is optically denser. Getting this? This is optically denser. Understood this? How to use the concept. Here we are learning that, but actually applications like this. So this kind of questions they 100% ask. Okay, write down. Next one. First write down. A ray of light falls normally. A ray of a light falls normally on the face of a glass, on the face of a glass slab, on the face of a glass slab, full stop. What are the values of angle of incidence? What are the values of angle of incidence and angle of refraction? Angle of refraction of this ray. Question mark. Second bit from the same question. Light enters from air to a medium X. Light enters from air to medium X, full stop. Its speed in medium X becomes 1.5 into 10 raised to 8 meter per second. Becomes 1.5 meter per second. Find the refractive index of a medium X. Find the refractive index of the medium is X. I'll repeat the entire question. A ray of a light falls normally on the face of a glass slab. What are the values of an angle of incidence and angle of refraction of this ray? Second, light enters from air to a medium X. Its speed in a medium X becomes 1.5 into 10 raised to 8 meter per second. Find the refractive index of a medium X. Find the refractive index of the medium X. So first question, what they are saying, there is a glass slab. Okay, in first part what they are saying, there is a glass slab and incident ray which incident on the glass slab normally. Normal means 90 degree. Okay, this is suppose I am taking the edge of the glass and the incident ray is perpendicularly incident on that into the glass. So it will not enter into the slab. It is what reflected back on the same path. So in this case, angle of I and angle of R is equal to what? 0 degree. So whenever they are penetrating through perpendicular or normally, then always the angle made by the I and R is always 0. Okay. And second part they are asking here, the light enters into the medium X. Okay. Suppose here we have a air and this is medium X, and they are saying the speed of the medium X becomes, means here speed of X is becomes 1.5 into 10 raised to 8 meter per second, and find the refractive index of the medium. So I want to find out the refractive index. So I know that N is equal to C by V. C is not given, then we have to take by default, that is 3 into 10 raised to 8 meter per second. This is the speed of a light in the air. Okay, so this is 3 into 10 raised to 8 divided by 1.5 into 10 raised to 8. 10 raised to 8, 10 raised to 8 cancel. So 1.5 remove the decimal, that is 15 by 5. So that also I will do 15 by 10. Okay, so 10 is get reciprocal, so 30 by 15, that is equal to 2. So refractive index of a medium X is nothing but how much? 2. It is a unitless, so answer is 2. Can you getting? These questions are for 3 marks. Everyone copied, getting up to here? Manthan, are you there? Anahita, are you there? Vidhi, are you there? Marva, Alia, Jivitesh, or everyone slept nicely? Copy this. Only Manthan is there. Okay. Okay. Vidhi is there. Alia, Vidhi, Marva, Jivitesh. Yeah. Write down next question. A 4.5 centimeter needle. A 4.5 centimeter needle is placed 12 centimeter away from the convex mirror of focal length 15 centimeter. Give the location of image and magnification. Give the location of image and magnification described what happens to the image. Describe what happens to the image as the needle is moved farther from the mirror. Okay, I will repeat here. A 4.5 centimeter needle is placed 12 centimeter away from the convex mirror of focal length 15 centimeter. Give the location of image and magnification. Full stop. Describe what happens to the image as the needle is moved farther from the mirror. Okay. So here needle size or needle height is given, that is 4.5. That means here height of the object is given. Height of the object is given. That height of the object, okay, is nothing but 4.5 centimeter. Always whenever this chapter questions will come, try to read the questions and write down the given quantities with proper signs. Okay, this is what your very first and basic task is there, and then we have to go for mirror formula. Okay, they are saying mirror, so we have to use the mirror formula. So here it is placed 12 centimeter away. So U is nothing but what here, 12 centimeter. Now this is which mirror is there? Convex mirror. No? So convex mirror, that means U is here, means left side. So U is always negative here. So this U is what? Minus 12. Now the mirror, the convex mirror have a focal length 50. So focal length is this side. So focal F for a convex is always positive. So it will become positive 15 centimeter is a focal length. Getting this? Then they are asking us to find out the V position and magnification also they are asking. So by using mirror formula, we can write 1 by F is equal to 1 by V plus 1 upon U. So we know the focal length and U, we can find out F, we can find out U, transpose 1 by U over here, it will become minus, this is 1 by V. So 1 by F is nothing but 1 by 15 minus U is also minus 12. So 1 by V, so minus minus plus 1 upon 15 plus 1 upon 12 is equal to 1 by V. Now find out the answer, how much will it come? V is 20 by 3, or if you simplify this, you will get plus 6.6 centimeter. Okay, you can write in the fraction or decimal form anything, and magnification M is nothing but minus V by U. So V I got here minus 20 by 20 by 3, and U is minus 12. Minus minus get cancelled. So 20 by 3 into 12. Okay. So 0. 6 ones are 6. 6 ones are 6 and 4. So I said 36 1. Something you will get the answer. Check. Is this same or 0.5? 0.55 something. Yeah. This is 5. That's number 45. Yes. 0.5 with positive magnification. Okay. This is magnification. So it's less than 1. That means image is smaller here. Means diminished we are getting. Okay, then they are asking what here, if the needle is moved farther away, means if you are taking needle away, then image size is what? Reducing. That's it. Okay, for writing, image is reduced if the needle is taking away from the pole towards the left side, then answer will become small, means the needle will become smaller and smaller. So for writing that, you will get 1 mark. Getting how to solve? Okay, copied everyone. So write down the next question. A student wants to project the image of a candle flame, on a screen 60 centimeter in front of the mirror. 60 centimeter in front of the mirror by keeping the flame on the screen 60 centimeter in front of the mirror by keeping the flame at a distance of 15 centimeter from its pole. So first bit, write down, write the type of a mirror he should use. Second bit, find the linear magnification of the image produced. See what is the distance between the object and its image. Last bit, draw the ray diagram to show the image formation. Draw the ray diagram to show the image formation in this case. Okay, I will repeat the entire question. A student wants to project the image of a candle flame on a screen 60 centimeter in front of the mirror by keeping the flame at a distance of 15 centimeter from its pole. So first bit is that write the type of a mirror he should use. Second, find the linear magnification of the mirror produced. Third, what is the distance between the object and its image. And last, draw the ray diagram to show the image formation. Okay, so try to solve this question. How we will get the answer? Check. So here student want to project the image of candle flame on the screen 60 centimeter in front of the mirror. Okay, so in front of the mirror. So if you take concave and convex mirror, you are getting negative only. Okay, but we have to decide which mirror is there. So first you can write down U is how much they gave object is placed, no, that is you image. Okay, project the image of the candle. Okay, image is there on this candle flame on the screen. Yeah, it is in front of the mirror. Okay, that means here V is given, which is of minus 60 in front of the mirror. That means here it is minus 60. Okay, so in front of the mirror, by keeping the flame at a distance of 15 centimeter, and U is given minus 15 centimeter. See here, V is negative, U is negative. That means here which mirror is used? Of course, there is a concave mirror. Here what? Concave mirror. Getting this? So because check, in concave mirror only we are getting both object and image on the same side. Only last case, whenever the object is in between focus and pole, that time only I am getting virtual or beyond the mirror, that image is getting. Here concave mirror is used. So this is the first, write the type of a mirror is used, that is concave. Writing this writing the correct distances, you get half mark. Sorry. Writing the correct distances, you will get half mark. And for identification, oh so not here half mark, for writing the correct identification of the mirror, you will get 1 mark. Then second, find the linear magnification. So as this is a mirror, so linear magnification is minus V by U. So here V is minus 60 and U is minus 15. So minus minus get cancelled. So minus 60 by 15. Okay, simplify this. 3, 1, here 2, choke. So minus 4 is the M. You are getting magnification is how much? Minus. M is minus 4, image is enlarged. Okay, and real and inverted. Then see what is the distance between the object and image. What is the distance between object and image? Now very important. So somewhere object and image is there. That means you can write here. This is very important. It's like calculating tube length. So 16 minus 15 you can do. You get the answer. So 16 minus 15 is nothing but 5 and here 4. 45 centimeter is the distance between object and image. Everyone is getting up to here, and still how many last bit is left, no? Yeah, ray diagram they are asking. So what is the ray diagram? Everyone can copy. I will draw the ray diagram. Okay, draw the ray diagram here. So concave mirror is there. So this is focus, this is center. So object is somewhere, kept it here. Then this is the first parallel ray passing through the focus. Another ray of a light, you can pass it from the center. You can take a scale and draw. Somewhere they are what getting intersected, and you will get the magnified image. Okay, you can do it properly. Mine is little, it's very worst. This is the concave mirror. And images we are getting what? Real and inverted. This is suppose AB, then this is A dash, B dash. That's it. Understood? So I will end this session today. So you all can come for test tomorrow. Okay.